Okay, so let's start with the expression and assignment statements. So this one is actually the seventh chapter of the book. We're still talking mainly about the imperative programming languages here. We covered what? Data types, names, all of these things. Now, I felt that we lost a bit the general idea of the course, so I prepared a few slides about like the bigger point. So what is the bigger picture of the course again, just to, get back to the basics? What is our main goal of studying all of this? The main goal is actually want to understand how programming languages design, so that's the idea here, impacts code quality, focusing on key principles like reliability and readability. So if you're wondering why in the previous data types and the other chapters, why we're like after explaining something, we'll say, oh, this has good readability, this doesn't have good, because actually the main idea for the course here is to go through all the concepts in general, to be able for you to be evaluate the programming languages, right? So we started with how to build the programming language, how to work on the grammar, all of these things. Now we moved to seeing actual programming languages. And based on what we're learning here, the concepts, you will be able to see, okay, for example, Java is good when it comes to this thing because of the readability. But then the disadvantage is that, you see, so we started about like understanding how do we even evaluate the languages from compiler-wise, basic grammar, all of these things. Now we move to actually talking about seeing actual example, because most probably you're not going to build your own programming language, right? But you should be able to actually evaluate the languages that you do. So by studying various language concepts and structures, we learn to what? To evaluate the programming languages more effectively. So that's what we're trying to gain from this course. And we want to be able to write clearer, safer, and more efficient code. So by learning these concepts, especially when we learn, for example, the names, the data type, implicit, explicit, all of these kind of things, will help you actually writing clearer and safer codes, and then select the right tools and techniques for different tasks. Now, again, we want to just remember the two main things, and because this we took in the first chapter, the introduction chapter, we talked about reliability and readability. Who can remind me what do we mean by reliability, that this code is reliable? What do you mean by that? Fail often. Very good. So fail often, that means consistency. Okay, so the idea here is that I want to build a code that has a consistent good way. Not like, okay, for example, the first 5 times it works perfectly, but the 6th time is not very good, it fails. No, we want to be we want the code to be reliable. So a program is reliable if it consistently performs as expected. Okay. Now, why is this is so important? Because it reduces the risk of unexpected behavior, improving user experience, of course. Okay, so this is just in general why this is important. Also, it will support code maintenance by preventing bugs. Now, some of the factors for enhancing reliability that we already covered, like what? Who can remember? From like the data type chapter, from the names and variables chapter, some of the stuff. Anyone remember anything? Yes, Michael. Type checking is one of the main things actually when it comes to make this reliable. Why? Because let's say you don't do type checking, you're implicit. We said you may be able, this code may not be reliable if you're making some mistakes that the compiler is not even noticing it. So type checking is the first one on the list. What else? Naming the variable. Naming the variables, yes, but it links more to the readability, naming the variable. Error handling is the other main thing, is the how am I going to be able to handle the error? And then memory safety. Where did we cover this, the memory safety? What did we give an example and you actually, Felipe? C. For example, the C, when we said it can what? Overwrite other memories, right? If it's not done in a good way. Do you remember when we said the string and arrays, for example? So this will make it not reliable. Even though readable-wise, it's very good, okay, everything is fine, but this is not reliable. Now, readability is what is simpler. What do you mean by readability of the code? Is that it needs to be able to be understood by others or by yourself, of course, because that's usually one of the main problems when we write code without comments and without naming them right. If you remember, let's say you're writing the code and you're naming everything X, Y, Z, A, B, C. And then you had the midterm, you had the final, so you left this project for like 3 months, and now you're going back to this code. It's not readable anymore for you. So the importance of this is simplifies collaboration and maintenance. So this is something very important, guys, that you're going to be forced to learn in a real company. And real companies who have done co-ops so far, programming languages stuff. Okay, it depends on the size of the company that you worked with. There is a step called what? Peer review. Who went through this step and their co-op peer review? So can you tell us what is the peer review? Very good. So as you said, sometimes it's informal, but in bigger companies, it's actually more formal. There will be like they will be using like specific softwares where you will submit your code, and you will need at least 2 other programmers working with you in the team, or sometimes in different teams. Why? Let's say your code is affecting a different area. Let's say, I don't know, you're working on collecting data, but this data collector is what is also used or like affects another part of the thing. So you will have one from your team, from the data collector team, and another programmer from a different team, and they have to approve, both of them, they have to approve usually your code before going into production, so you don't break things. Because usually in bigger companies, you'll have lots of different code, they have to merge it together and all these kind of things. So if your code is not readable, what's going to happen? You're going to get some sarcastic emails, some tough emails sometimes, or we can not understand anything, all of these things. And if they CC your manager, that's not good for you. So usually readability is very important, even from a selfish point of view of working, right? But in general, it's actually one of the main things to have your code, like to make it more readable. Now, it also reduces the cognitive load required to understand complex code and facilitates code reviews and debugging. Actually, one story that happened with me, I remember the company that I used to work with, they had the older codes like built in C, and we're not using them anymore. So they went and they upgraded everything to C++ and all of these kind of things. So what happened is that one of the very few companies that they used to get this product from the company that I used to work with, they're still using the legacy code, so this old code, but no one is supporting it anymore. And I remember one time there was a bug in it. I was trying to read this code to fix the bug. I'm not able to understand anything. The problem, this code was old enough that the person who wrote it retired. So I can't even go to ask him what does he mean. So to fix a simple bug, it took me over a week to actually just understand the code. What did he mean by writing this line, all these things. Now, of course, with the newer version, the company went to something much more ordered, much more commented, all these things. But this actually wastes lots of time. So imagine wasting a full week in the company to fix a small bug. Some factors that we've learned, as Felipe said, was in the name and the variable chapter 5, I think. Comments and naming here, correct? So comments and naming, and then consistent syntax. Where did we learn about consistent syntax? Which chapter? What do you mean by consistent syntax? What did you get in your midterm? It's all about what? Syntax errors and grammars and all of these things. So we spend lots of time talking about the syntax form, right? Have consistent syntax. And then there will be the logical structure and all of these kind of things. Now, if I want to connect the reliability and readability, thanks to the chapters that we've learned. We talked about syntax and semantics, right? Like the first 3 chapters, we covered syntax and semantics, and understanding these will be able to help us avoid errors and misinterpretation. Who can give me an example? How can understanding the language syntax or semantic will help us avoid errors and misinterpretation? How? Like a very clear example that we've worked on it a lot, and the midterm, we've used it. So if I'm giving you a syntax, a grammar, okay, what did you learn in this couple of chapters to do to be able to avoid misinterpretation? Let me see new faces. Yes.
Down and bottom up.
Yeah, so why did we do these things?
You would either see.
Exactly. One of the things that we've learned is avoiding ambiguity. So if you have a grammar, right? If you have something and it's ambiguous, that's a problem. So learning these things helped us actually avoid errors and misinterpretation of the syntax aspect. Data types and structures, we've already, in the past couple of lectures, choosing the right type can improve reliability and make code self-documenting. And then now we're going to learn more about the expressions and assignments. So this chapter is about expression and assignment, which will help us to proper use of expression and choose predictable behavior. Predictable behavior falls under what? Readability or reliability?
Reliability.
Reliability. Okay, you need to know these basic stuff, guys, if I ask you about them. Also, I want you to remember, so this is kind of like the conclusion so far. Reliable and readable code not only works as intended, but also stands the test of time. So that's something very important. So our exploration of language concepts, so the concept that we're learning through this course, should be tools for you to help achieve these qualities. So what do we kind of like summary of why we're learning this course is we're seeing lots of tools through the chapters that will help you actually improve reliability and readability of your codes. Now let's start with the chapter. Okay, so expressions are what? Are fundamental means of specifying computations in programming languages. We know that. And then it is crucial for a programmer to understand both the syntax and semantics. We've talked about this so many times, correct? We've covered syntax in lots of chapters. This chapter, we're going to now move a bit on semantics again. So we're going to visit semantics because syntax is very clear for us so far. If I give you int a equal 2 and I don't put a semicolon, this syntax error is very easy now. We want to revisit the semantic, even though we've worked on semantics, right? We've talked about semantics when we talked about ambiguity. Ambiguity, the syntax is correct, but because of the semantics are not very good. But we've talked about them from very theoretical point of view, building a grammar. Now we're going to actually see them in some of the languages. So we said a formal mechanism like the BNF is used to describe the syntax of expression. In this chapter, we're going to focus on the semantics. And to understand expression evaluation, we need to be familiar with the orders of operator and the operand evaluation. So that's why it's not very hard. There is no complex concepts at all in this chapter. It's just like revisiting some of the basic stuff that you know already from programming, but in a structural way. So we're just going to put them in a structure. Now, again, we're focusing a lot on the imperative languages now. Fortran. Out of curiosity, who knows about Fortran? What is Fortran? Anyone is born in the 60s? 50s, 70s, no one, huh? Okay, so Fortran is one of the oldest programming languages. But why am I actually talking about it here? Because actually it was the main idea behind Fortran was to design a programming language to solve arithmetic problems. Because before that, people used to use the machine code, assembly language, all these things to even write like the simple a plus b equal 5. And this was usually very, very annoying, all things. So the whole, or the main goal was to produce the first high-level programming language is to actually just work with arithmetic programs. And that's why even the name is formula translation, like out Fortran. And then Fortran, from Fortran, we got all of the newer programming languages until we arrived here. Okay, but that was actually the main idea. Another fun fact is that even in the beginning, it used to only support numbers, like it didn't even support text back then, okay? Now, so we know that the main goal that a high-level programming language was to solve arithmetic expression. That means they are important to know a bit about, right? So arithmetic expressions structure is what? It will have four main things: operators, operand, parentheses, function calls. You know these, they're very basics. Operators are the plus minus, operands are the A as an operand. What does this structure allow us to do? If I have this structure, okay, so I'm able to have an operator, an operand, parentheses, function call. So why is this beneficial for me? Is to be able to actually build something complex. So if my program is able to support many things, it's like what I'm able to mix and match, right? So it will build complex expressions by combining multiple operations in a single line. So this may seem silly, but it's not silly. Why? If I'm working on readability, this is important for me. If my programming language is able to, in a single line, just a single line, be able to write something that is complex, is this better readability than doing this in 5 lines? Yes. Now, because most of the popular programming languages you work with, this is something given, like you expect it. But originally, no, it was something actually very big that to have one line of code will do all of this for you, right? So again, if I want to talk, two main things we're going to cover, know the terminology of it: binary operators and unary operators. So what is a binary operator? It's something that you can add two numbers, for example, like A plus B. We're going to call this, the plus is what here? A binary operator. So a binary operator requires two operands, A plus B, for example, A times B. So that's a binary operator. Now, you know that, is this usually infix or prefix? And usually in Java, C++, C, it's infix, A plus B, correct? But actually, there's other languages that's not very as popular as now. They use it before. We plus AB, that means A plus B, okay? And usually, if you took the programming paradigms, Scheme, for example, is very famous for this. So this is called prefix notation and then infix notation. Perl, for example, also has a few operators that can be used in prefix form. Yes?
Java can use prefix too, right?
Not for binary operators, for other things. Unary operators, that's where we use sometimes prefix and postfix. So for the unary operators, they're what? They're like the minus, like minus A, like -5. So it needs only one operand, okay? What other than the minus, like a negative number can be? What is another unary operator that needs only one operand, not two, that we always use, especially in loops, for example? What do we use? Michael?
Plus.
Which is what? Do you use increment or decrement? That's plus plus. So it needs only I plus plus. That's also called unary operator. In this case, it can be plus or minus, or it can be the plus plus or minus minus. Now, prefix, unary operator usually appear before the operand, but majority of the, or like all the C-based languages, like Java, C, C++, they do it like this, A plus plus, okay, or A minus minus. Now, what did we learn? Each time we're going to talk about something, we want to check what is the design issues. Because if I give you Java, and I'm telling you, okay, about arithmetic expression, analyze this or evaluate this Java for me. So how can you do that? You're going to check the design issues that exist. Is there any design issues in Java, for example, or C or C++? So what are some of the things, if I'm giving you A plus B, Again, now here you want to switch to thinking like what? Like a machine. So I'm giving you like A plus B times C. So what would you think? Because A plus B is clear, A minus C, A times B. If I'm giving you A plus B times C, where did we see this? Mateen. Before that, when you say A plus B times C, so before that. And remember here, what did we say in the slides? In this chapter, we're going to focus on syntax or on what? Semantics. Michael.
Ambiguity.
Ambiguity. A plus B minus times C may be ambiguous. That's what we called it back then. Why? Because of the... Exactly. So this is from a low level. Now, if you want to think about from a general level, why? So if you can give me an example, if I have A minus B times C. Exactly. So, for example, the machine needs to decide, am I going A minus B and then the output times C, or am I doing what? B times C and then A minus this output, right? Do you remember? We covered this a bit and we talked about, but we covered it more from a low level, from a parse tree, from like a technical perspective. Here we're thinking about it from semantics, from just understanding. Before learning about the LL grammar, we said there's two things usually will help us to solve this. That each language need to think about these two things to be able to work with semantics. Who can remember these two things? I'll remind you, precedence and what else? Associativity. True. So operator associativity and operator precedence. If you don't remember, we're going to talk about it a bit. So we covered this, and then I told you, for example, for the midterm, now we're going to go with the LLA grammar because it's more formal, because you're actually building the language. Here, we're going to check, for example, some of the popular languages, how do they choose their precedence and the associativity? Because if I'm Java, if I'm looking at this A minus B times C, how is Java reading this? The one who designed the rules in Java should have covered the precedence and associativity, right? For the machine to follow them. And then another things we're going, from design issue, we're going to focus here is the overloading. We're going to talk about it. This is important for us. So A plus B times C. What will happen, as we said, if I have here like 3 plus 2 times 5, so I have two options, right? It's either 3 plus 2 times 5 or what? 3 plus 2 times 5. Okay, how am I able to solve this? If I'm reading from left to right, or if I'm reading from right to left. So that's what I need. So that's what actually need to be covered. So let's go step by step here. So does this have a syntax error? No. So it's passed to me. There's no syntax error, but there is a semantic problem here. How can the program understand this? Keyword here is understand. That's why we're talking about understand about semantics. The value of an expression depends at least in a part on the order of evaluation. We call it what? Order of the evaluation of this expression. So suppose the variable AB 3, 4, 5, as we said, is going to give you the first option, going to give you 35, the second option 23. It's not good. Is this code reliable? If it's like by random, sometimes we'll choose right, sometimes we'll choose left. Is this reliable language? That's not reliable. So there is a design issue. You see, that's how we're like thinking about it. There's a design issue that's not reliable for this specific language that doesn't follow. Now, if you're designing the language, how are you going to choose this? Based on what? You're building the grammar, you're building the rules, and you want to fix this to make it very clear. So how are you designing it?
I would design the arithmetic rule. So like something times something goes first, then something plus something.
Okay, one answer. Who has a different answer?
The easiest way to fix this technically is to have throw a syntax error if it ever has an ambiguity.
Yes, but you're thinking too much from technical perspective. Like you're designing this, so you shouldn't even fix it. You're designing it to work. To work, you know what I mean? Why? Because if you want to have this as it has an error, this language is not very practical now. You want it to be as practical as possible for user interface, user experience, in a good way.
Practical and intuitive, we can just go with the operations.
Very good. So the same thing as Felipe. So actually, that's the answer that I want to hear. You don't want to reinvent the wheel. So why would you even come up with new rules? There is the rules in math. What are the rules in math? Multiplication and division are before addition and division, correct? So just follow the math rules. Now, if there is something that is not covered in math, you're building a different program, that's something different. Okay, but here it should be very easy for you if you're designing, because let's say you are hired in a company to design something like this, and then you start inventing rules instead of just reusing what's there, what's very common for people, it's going to be a big problem. So instead of simply evaluating the operators in an expression from left to right or right to left, it shouldn't be random. Mathematicians developed a hierarchy. For example, multiplying takes place before addition. We should use the same thing here. So that means the precedence rules, the precedence rules for expression evaluation define the order in which adjacent operators of different precedence levels are evaluated. So what do you mean by that? The rules are based on the hierarchy of operation priorities as seen by the language designer. So again, as Felipe is the language designer, he's going to choose these rules. So these are the typical precedence levels. Usually, these are the ones that you want to order. You have parentheses, you have what? Exponentiation. Now, this is not covered in all of the languages. Some of the languages, I think maybe in Java, you have to follow a library or something. Other languages support this. But if the language support this, this is going to be what? Taken as a priority before the unary operators. What do you mean by unary operators? Like the plus plus or just minus, like a negative, and then multiplication, then addition and division. Now, when it comes to unary operator, in all of the common imperative languages, the unary minus operator can appear in an expression either at the beginning or anywhere inside the expression. But, so if I have this minus A plus B, I don't need parentheses here if it's in the beginning, okay? But if the minus is inside, it's not going to work. It's going to be what? There is a problem in the semantics for the machine to understand it. That's where I need parentheses, for example. If I have this A plus minus B times C, this is legal. It's going to understand it. But this one, usually it's not legal. And if it's legal, if I show you a language that actually supports this, you're going to tell me, no, there is a design issue here. This is like, you know, it's not very clear. Readability-wise, it's not clear. Other things, it's not very clear. It may work, but if I'm able to choose one of them, I'm going to choose the first one. It's just better for even user experience, correct? So that's the idea. You have questions?
So in order to solve this, would that be something the designer would have to deal with at the syntax level?
So when you're putting the grammar fits syntax and semantics. So yes, here, if you dealt with it on a syntax level, this is going to give you syntax error. And this one here. So you're right. Like if I don't support it in this, it's syntax error. So of the common programming languages, only Fortran, Ruby, Visual Basic, and Ada have the exponential operator. Other ones you have to, I think, call a library or something. And all four exponential has higher precedence than unary minus. So that means if I have this, I'm going to solve this first and then add the minus. Okay, so that's how, it's not like I'm going to solve, that's how the program is reading it. It's going to read this first and then the minus. These are some of the different programming languages like Pascal, C-based, Ada, the order of the precedence, like which has higher priority. Now, the other rule is what? Associativity rule. Do you remember when would we even use it? Because the precedence rule is enough for me. So why would I waste my time and write another rule? Do you remember a bit from previous chapters? About this case. This case is actually, again, mathematically, you can do A minus B plus C minus, that's fine. But for the machine, it needs a specific rule to follow. Okay? So usually, if the operators all have the same level of precedence, that's where the associativity rule is going to come handy. So in this case, the precedent rules say nothing that where the associativity rule is needed. So the operator associativity for expression evaluation define the order in which the adjacent operators. So for example, typical associativity, that's why we're saying typical associativity. That's in general, of course, we're going to go from left to right. But in the case of exponentiation, we cannot go from left to right. Why? For example, this case is left to right, A minus B plus C minus D. How is this solved? It will look like this. So A minus B first, then the plus C, then the minus D, okay? But with the exponentiality, the exponential, no, we're going to do B and C first, and then AB, okay? Why? Because think about it like this, as if we're doing like A, and then B also times C, like, so you have to solve this first to be able to use it with A, correct? Notes, can a programmer alter the precedence in associativity? Right away. How?
With justice.
One very easy way, Samuel. Parentheses, very easy. Because if I have A plus B times C, if I add parentheses here, I'm forcing what? The machine to read A plus B first. I'm forcing it, right? So this is one way to alter the precedence, actually. So if I ask you, is there a way? It should be yes. How? By placing parentheses. And this is an example. Now we're going to move to the conditional expressions. So not that we were done from the arithmetic expression. What else conditional? What do you mean by conditional expression? If statements, right? So if then else statements can be used to perform a conditional expression assignment. Now, how are these things? Now it's a bit more complex, like the math basic stuff. Now, I have this program. If count equals 0, average equals 0, else average equals sum divided by count. In the C-based languages, guys, they have this thing that you can write this whole thing in one line. Why? First, less line of codes, right? Maybe faster. There's different things. We're going to look at the design advantage and disadvantage. But how can you turn this into one line using this rule? So when you're designing the language, you said, you know what? I want to do something like this, like this. So expression 1 is what? Is this one. The count equals 0. Expression 2 is this one, and then expression 3 is this one. Okay? So if I want to use this to convert this into a language, into one line, what would it be? Who can do it? Yes.
Average equals 0, so I can mark 0, and colon sum divided by 2.
Actually, if you write this in C-based languages, you're going to save all of this. Just one line. But you need to understand what is this, okay? Now, in addition to C-based languages, conditional expression are provided in Perl, JavaScript, and Ruby also. They support this conditional expression. Now, can arithmetic operators be used for more than one purpose? Can they? More than one purpose. You want to say? You're
add strings together.
very good. Some of the languages, they will have a powerful thing, for example, like an advantage that, okay, I'm going to use the plus to also concatenate two strings. So it's not going to only be But, okay, now you're a machine, right? You're seeing a plus. Should you use it for an int or as a string? What are you like? How can you solve this from a compile perspective? Are you going to do a syntax error?
We have operator.
Hmm?
Overload.
No, we're going to talk about it. But like, I mean, from just like thinking out loud, how would you deal with this?
Do you look at exactly what the thing's having? Like the children's one?
Yeah, but what is the keyword? We've learned it in the previous chapter, Ibrahim. Data type. So you're going to look at the types. So if this int type, I'm going to use it as plus for the integer. If this is a string, I'm going to use it for that. Then when would the problem be? Sometimes if, I don't know, if the language support implicit typing. So it's not explicitly telling the compiler that this A and B are explicitly int or not. Like in Python, we can say A equal 5, and then we can say A equal string, for example, correct? Okay, so very good. So yes, for example, plus can be used, specify integer addition and floating addition. Some languages like Java also use plus for string concatenation. This multiple use of an operator is called operator overloading. So that's the official name to it. That's called operator overloading. That means I'm overloading this to support more than one thing. It's generally thought to be acceptable as long as neither readability and reliability suffers. So this is very important for us. You cannot just answer right away, is overloading good or bad? It's going to depend. When you use the overloading, did it affect readability and reliability? If not, that means it's a good thing. When overloading can be resolved by contexts. As we said, type, data type. So that's the context. I have int here, I can solve it. So when all operands have known types, it's clear for me and explicit data typing. For example, 2 plus 3, A plus CDE, that's very clear for me. The compiler is going to be able to solve it. But there is also potential trouble. What can that trouble be, guys? I gave you a hint in C++, Mateen. Okay, so this is the thing if you're, for example, having different data types. In C++, who's taking the course in C++, we have some operators that they are confusing. Why? We covered them a bit here also in the, what is this? Okay, so and C++ can be used for what? For having two operands to add in, for example, and like the what's called the logical operator, but also and is used for, Michael?
The address.
For the address. So in this case, a binary operator will work like a logical AND operation, correct? And then unary operator, it means totally different. For example, if I have this, it means what? The address of Y will be put in X. So this can have a potential overloading. I'm using the same thing for two different things. So let's say I don't have the names very well. I didn't design my naming stuff very clearly, all of these things, and I just missed one variable. I missed like typing it, like I deleted it by mistake. Would the compiler stop me? No, because this can be used as what? As a unary or a binary, both of them. So you may not get caught in the syntax error. It's going to be passed, and then you will have a problem. So what are the problems in this case? Loss of readability. That's one of the things, because some, of course, it may be confusing. You're using the same thing. And the other one is loss of compiler error detection. This is very important. As I said, let's say you deleted a character by mistake. So So first, for example, using the same symbol for two completely unrelated operations is determinal to readability. Why? When we use plus, and also we have, for example, when you use the minus, like A minus B, but also we have minus B, still related, right? Like negative, this is, but in this case here, the and has nothing to do with the address, right? It's completely different. So readability-wise, some of the readability is going to be lost. The other thing is that, as I said, the simple keying error, so if you just made a simple mistake sometimes, leaving out the first operand for a bitwise AND operation can go undetected by the compiler. Now, there's something called user-defined overloaded operator. So the one that we gave an example, like the AND, is already designed in C++. But there's something in C++ you can do is called user-defined overloaded operator. What do you mean? You can actually yourself transform the multiplication symbol to something else. You can do it yourself. Suppose the user wants to define the multiplication operator to multiply each element of an integer array by a scalar integer. Yes?
Can you not do that in Python as well?
Maybe. I didn't check it, but like this from the slide of the book, it says C++, C#, and F#. So most probably you can also in Python. We said, yeah, for example, you want to use this to multiply one int with an array. So let's take a look at it. How can this be done? We're going to just implement it by writing a function subprogram named this symbol, right? So the same symbol. But now, how would the compiler handle this? The compiler needs to be able to handle this. So the compiler will automatically select the correct operation based on the operand types similar to the built-in overload. So the same way we talked about, let's say these are two ints, I'm going to use the plus for this. Two strings, I'm going to use it for concatenation, for example. What is the advantage of this, if you think about it? The advantage of this. More faces. Advantage. Usually we talk a lot about what? Readability and reliability, correct? So which advantage here if I'm doing something like this? Is it better readability? Why?
You already understand what the operator was.
So imagine doing this, A times B plus C times D, instead of writing this. You know, for example, it's very simple, very clear, all of this. But also, that's why we said overloading depends a lot. You cannot just give it like, okay, it's always better in readability or worse. Who can think about like a case where it's going to be bad for readability? If you forgot about it, for example, who else? Like, think about someone who didn't attend this class and he's trying to do the overloading.
Doing like multiplication of vectors, doing cross product or dot product.
For example. But something like much more, and you're going to laugh on this, but this is actually done. If you're learning just stuff out of YouTube without understanding the concepts, you're going to have stuff like this. Imagine you decided to define the plus to mean multiplication. Can you do that? That's the problem with C++. You can actually do it. No one is going to stop you. So imagine you're just like playing around and you did this. And then, for example, you forgot about it at some point or whatever. It's a problem, right? That's why it's important to take this class. So when building a software system from modules created by different teams, that's also another thing. Let's say there is different teams and you're not communicating with each other. You use this operand here for something and someone else used it for another thing, and then you didn't communicate well about it. It's a problem also. Now this one, the correction, we covered it in one of the chapters, if you remember. We're going to go through it very quickly. So this is related to type conversion. If you remember, we covered it when we talked about strong typing. Can remind me which Which language we said has strong typing? Java, exactly. We compared it with other things. Now, one of the design decisions, and this is always very important, we're always talking about the design. The design decision concerning arithmetic expression is whether an operator can have operand of different types. Correct? So that's one of the problems, because we said the compiler, if you're giving two same data types, it's fine. It will depend on itself. I'll deal with it. Don't worry. But what if I want to do it for different types? So here, from a design level, you need to take this decision, and you need to take responsibility on this decision. So if you allow this, you can't blame the compiler if there's something wrong. You have to find a solution for the compiler. So what's going to happen? Language that allow such expression, which are called mixed mode expressions, must define conventions for implicit operand type conversions. So you have to define something for the compiler to be able to use it. So why? Because we said computers do not have binary operations that take operands of different type. Built-in, like from the computer-wise, we don't have this as a built-in. You have to actually help the computer to take the decision. So as we said in chapter 5, we talked about the correction was defined as implicit type conversion. If you remember, we said that means what? Let's say you're adding an int plus a float. You don't have to do the actual casting. We can do it right away. So this is called what? Correction or something. So no, type conversions. Now, if you're doing an explicit conversion, it's not corrections anymore. It's what? It's called casting or explicit conversions or whatever. So when using an operator and expression, the operand involved are expected to be of the same time. That's why we need to deal with it. However, if the operand of different types, like integer, floating point, the language must handle this mismatch. So how this is going to happen? How does the compiler decide? It needs to decide which operand should be converted to. For example, I'm doing int plus float. Let's say you told the compiler, I'm allowing this in my language. I designed this language to allow this. Which one? Should I convert the float into an int or the int into float? So that's where usually you have to actually do this decision. Some of the languages will tell you, okay, that's how you convert. This has a higher priority than this. Other languages will do other things. So these actually are different from language to language. So different language approaches. Language designer handle the correction differently. Restrictive languages, some languages limit the correction aiming for better type safety. Why? We talked about it when we talked about the Java. It's strong typing, better type safety. It will give you an error, so you can detect this error at the compile time. You don't have to actually pass the compilation and then there is a semantic error somewhere else. This makes the code more reliable, as the compiler will alert programs about type mismatch. Flexible languages, other languages support a broader range of corrections focusing on flexibility. Very good. So let's take an example. So here we said it's the programming responsibility or the compiler responsibility. The debate centers around whether it should be the programmer's responsibility to ensure types matches, making the program more explicit and reliable. The better you're making your language when it comes to explicitly data types, all of these things, the better it will be for the compiler. Then there is the other one, like Python, for example, tell you, no, you know what? We're going to make the compiler handle everything because it will be just easier or more flexible for us when writing this. So there is always what? Pros and cons when you're designing the language. If we take this one, int a float b c d, d equal b times a, what's going to happen? In this case, assume that the second operand of the multiplication operand was supposed to be c. For example, you made a mistake. You're supposed to have b times c, and you did b times a. You need to take the decision when you're building this programming language. Are we going to give an error here, or we're going to let it pass? So that's the decision that you need to make. Because of the mixed mode expressions are legal in Java, the compiler would not detect this as an error here, even though I think, if I'm not mistaken, let me copy this. Let's do this. Java. So what are we trying to do here? We have int x equal 5, double y equal 2. Then we're going to say double result x plus y. So I'm adding an int plus the y. Here it's a correction, so it should pass. Here, if we do this, this is what casting. So that's what we should be expecting. In this case here, Java will allow, if it sees int plus double, it's going to choose the double to be converted to, not as an int, for example. In this case here, I said, no, I'm casting it into an int in this case. Okay, so what's going to happen if I delete this? Error, because I'm having int here, and this is a float. I cannot add them. Okay, yes?
I was gonna ask if, like, what happens if you change that double? Thanks.
This one here. This, I think it will not work also.
Yeah,
It's the same thing. It will not work. Because if you have the double, the program is able to transform into double, but not the opposite one. So that's like, so these are all design things. Like you have to think about it. So when they design Java, okay, the advantage of this is that, the disadvantage is this. Type safety is very important for us. So we're going to allow this, but we're not going to allow that. In C, unfortunately, for example, they didn't pay attention too much to this. That's why in C, no, you're going to have actually problems. Let's go back. Now, very quickly, I'm going to go through the Boolean expressions and the assignment because these are very clear. Of course, you know what is the relational expressions, right? They're like the greater, equal to, not equal to, all of these things. They are also dealt with. And then examples, very clear stuff. Common use, frequently used in control structure. That means very important for us to use these things mostly in the if statements to make decisions. Now, logical expressions are more like Boolean stuff. So we're going to have the and, or, and the not. This is example, and then we have this. The way logical expressions are dealt with in programming languages, they are called lazy evaluation, which is short circuit evaluation. That means what? If I'm having this, I'm looking at this one. Okay, at the first one. If this one, it didn't pass, I'm not going to continue. That's how the language is designed. Okay, which is better because if A equals 0, if I continue doing this, B dividing by 0, I'm going to have a problem. Now, who remembers? I think it was. Who remembers that we said the Boolean type before C99? What was the problem with the Boolean type before C99? We talked about. And everyone was shocked. Before C99. So at some point, C, we said didn't support Boolean. You remember, we didn't support Boolean. So no Boolean type, instead of numeric values, represent Boolean logic. So we used to be, you have to use 0 and 1. So you have to use int. We didn't even have a Boolean type at that point. So for example, if I'm using this, Boolean is true, it's going to give an error pre-C99. But how did they solve this issue? They used to do something like this. So instead of Boolean, they used to put int, and this is going to solve things. They are going to treat 0 as false and other non-zero values are true. So that's how they solve this. Now, which one is better for us, having Boolean types or not? For readability, for example. Boolean, of course. So relational expression potential issues in C. C allows expression like this, by the way. A greater than B greater than C. If you put this in C, it will work. But in Java, I don't think it will work in other things. What is the problem with this? Yes, that's fair thing, but Other than that, let's say you solve this through the system. You gave enough rules to go from left to right. But what's the problem?
We'll evaluate A, depending on associativity, we'll evaluate A is greater than B, we either get 0 or 1, and then we compare that to C instead of getting something.
You see, that's one of the main problem here. So look at this. Let's say you have int A equal 5, B equal 3, C equal 1. What's going to happen is that I'm going to say, is 5 greater than 3? Because that's what I'm asking, because this is what is the relational thing. It's going to either say yes or no. It's not going to give me anything. So if it says yes, that means returned 1. Now I'm saying, is this 1 greater than C? So why do I need this? You know, like, it's not very practical. So this is not very good, usually, but it actually allows it. Now, if you look at this, if we copy this in the C language, So, what was the error? Where did I delete the int here? It passes fine, you see? It gives me 0. Why it's 0? Because C is 1, and I'm saying, is it greater than 1? So if I put 0 here, it's going to give me 1. That means, okay, 1 is greater. But now if we go and use the same exact thing in Java, this is not going to pass. It's going to have an error. Okay, trust me, it's going to have an error. Okay, let's continue. Boolean expressions in C issues, we said readability is a big issue now, right? Because both of them are, I'm having int for Boolean and int for int, right? So this is not good. So conclusion, for clarity, language should include a dedicated Boolean. That's very important for you to always remember. Now, assignment and programming, assignment is very clear. It's either equal or what? Equal. That's when I'm using the double equals used for equality comparison, not assignment, right? Common patterns, we know all of this. Now, mutable versus immutable. We know that these variables are mutable, of course. If you have x equal 10, you can change it. We covered this. In which language variables can be immutable? You remember? And functional programming languages. We said in functional programming, like Haskell and other things, and actually can be immutable. Now, multiple assignments, this is another issue between C and C++ and Java, for example, like Python, JavaScript, they will allow this. Sorry, between Python and Java. So you can actually do something like this. That's called multiple assignment. And JavaScript, the same thing. But C++ will not allow this, and also Java doesn't support this. You cannot have something like this. But what can you have? How can you put them on the same line? If you wrote them like this, int A equal 1, B equal 2, C equal 3, it will work, but not like this. Okay, so that's another things also, guys. Increase readability and reduce code length, actually. Benefits versus limitation. The benefit here is that you're going to reduce the lines of code. You'll improve readability. What are the limitations? Time, compatibility. All variables must be compatible with assigned values. They need to be the same thing, like either int or all of these other things. And that's it. On Friday, we're going to do WOOC labs to cover this and the previous one. Good? Okay, thank you.